In this video, we'll look at an industrial network called Modbus. Modbus appeared in 1979 at a time when the Internet didn't exist yet. It's still very popular in industry. Originally, Modbus was built on a serial bus that connected different devices called secondaries, or slaves, and a primary called master that manages communication. Each secondary has a unique number or address. Addresses are between 1 and 247. The primary doesn't need an address since all communications take place with it. The primary sends a request to a secondary, and the secondary responds to the primary. Direct communications between two secondaries are not possible. A Modbus device can handle two things through registers: relays that can take a binary value on or off. If the primary can modify the state and, of course, read it, it's called a coil. If the binary value can only be read, it's a discrete input. Modbus also uses 16-bit registers. They are used to represent a value like an electric current, temperature, rotation speed. Similarly, if you can only read the value, it's called an input register. Otherwise, if it can also be modified by the primary, it's called a holding register. A Modbus device can have up to 9,999 registers of these four categories. Modbus is a request-response protocol. The primary sends a request to a device's address to read or write one of these registers. A Modbus frame is a sequence of characters starting with a byte containing the secondary's address, followed by a command or function code specific to each register category. 1. To read a coil. 2. To read a discrete input. 3. To read a holding register. 4. To read an input register. 5. To write a coil. 6. To write a holding register. The rest of the frame contains the data, followed by a CRC, to validate that there are no transmission errors in the frame. The data part can be different in the request and response. For example, to read a holding register, the request contains the address of the first register to read and the number of registers to read. And the response contains the number of data transmitted followed by their values. To write to a register, the frame data will be the register address and the data to write.